Hi students, welcome back to Physics with Ashwini. In this session, we will see relative velocity in 2D and mostly we will deal with river swimmer problems. There are some PYQs related to this topic. We will also discuss them in today's session. And have you understood the previous class concepts? And have you made your practice? Because that's very important because your NEET exam is very fast approaching. You have only 1 month time left. So kindly make a proper action plan and please be determined to your plan and do as much hard work as you can. Okay, because it's really the crucial time and I want every one of you to keep your 100% efforts. Okay, so without wasting the time, let's jump into this topic. Relative velocity. I told you right in 1D, what is relative velocity? Velocity of one object compared to the velocity of another object. In the case of relative velocity, both objects will be in motion, both will be moving. So how you compare velocity of one with the other, that is relative velocity. And we will see it in 2D. And most important problems, which are coming very frequently in your NEET exam is about river swimmer problems. So we'll see directly them. So let this be the river. And as indicated, let this be the direction of river flow. River is flowing in forward direction. Let this be the shore. Now, what about this? Can I consider this as width of the river? Let this be D. Let us assume point A. There is a swimmer here and he want to swim from point A. He want to swim from point A to point B. Imagine he started swimming in the same direction A to B. Can he do that? Is that possible? Or will there be any disturbance to his swimming? Those who know swimming here, they'll understand very clearly. There is a person, imagine myself, I was trying to swim from A to B, but the river is also flowing here with the speed VR. This is the direction of river flow. Let its speed be VR. This is the speed of the swimmer Vs. What will the river do now? Don't you think it will push the swimmer forward? Because river is flowing, right? So because of this push, what happens to the actual direction of the swimmer now? He will be moving in this direction and he'll reach some point C. Instead of reaching B, he will reach some point C. He thought of reaching B, but that was practically not possible here because the river is pushing the swimmer. River is also flowing, river is also having some velocity. So because of that, what happens? The river will move from A to C in reality. A to B was his expectation, but what was the true case here? He will move from A to C. And what is this gap? The gap between the point of his expectation and the point of the true destination. What is this distance called? This is called drift. Got my point, everyone? This is what actually happens in crossing a river, right? Now, there are two cases in this: crossing a river in a shortest path and crossing a river in a shortest time. First case is crossing the river in shortest path. Now, there is a swimmer who knows this relative velocity in 2D very well. The swimmer is very intelligent now. He knows this idea. If I try to swim in AB, river will push me and I will be reaching point C instead of point B. He has this clarity. Okay. And what is the shortest path here, beta? A to B is the shortest path. If we swim from A to B, then it means that crossing a river along shortest path. But that was not possible. How can we make it possible? So the swimmer is intelligent, as I said. So what he will do is, this was AB, right? Now the swimmer will think, I will swim in this direction. This is the velocity of swimmer. In this direction he was swimming because he knows that if I swim backward, The river will push me, and so that I will fall exactly onto the same place AB. Understood this point? So the swimmer has to swim with certain angle from AB, because the river will push him and he will fall at AB. Ma'am, how can you say that he will fall at AB? We don't know how much backward he was swimming. So that is why we are assuming backward with certain angle theta. With some angle theta, he was swimming. So after river push, what happens? He was falling at AB exactly. Now this is the shortest path. So in order to cross a river along a shortest path, the swimmer has to swim at an angle theta backward. Got my point? So we'll simplify this now. You are pretty clear with the direction of the swimmer. This is the direction of the swimmer. And what is the direction of the river? This is the direction of river. Now we got a triangle here, right angled triangle. Now if I take sine theta, what do we get? It's opposite by hypotenuse, right? What is opposite side here? It's nothing but velocity of the river. And what is hypotenuse? Velocity of the swimmer. And what is this? This is sine theta. So sine theta is velocity of the river by velocity of the swimmer. Important. If a swimmer has to travel along the shortest path, he has to swim with certain angle theta from the shortest path. And what is that sine theta? VR by Vs. Velocity of river by velocity of the speed. Clear. See, where is that theta? That is also very important. He knows that. See, what is the shortest path? The perpendicular path is the shortest path. This is the shortest path. From this shortest path, he has to swim with an angle theta. This clarity is very needed in solving the questions. Clear with this, everyone? Now, we'll see some PYQs. The speed of a swimmer in still water is 20. So, what is the speed of the swimmer? It is 20 meter per second. In still water in the sense, it's not relative speed, it's a normal speed. The speed of the river water. So, what is the speed of the river? It is 10 meter per second and is flowing due east. So, this is the direction of velocity of river in east direction. If he is standing on the south bank, okay, he was standing on the south bank and wishes to cross the river along the shortest path. Our first case, he wants to swim along the shortest path. So, what will be the shortest path? The perpendicular path is the shortest path, right? This is the shortest path. A, B is the shortest path. Now, the angle at which he should make his strokes with respect to north is given by. So, with respect to north, at how much angle he should swim? So, as I told you, for shortest path, what did I tell you? He has to swim at an angle theta from shortest path, right? So, this should be the direction of swimmer. And how do we find that angle? Sine theta is equals to velocity of river by velocity of swimmer. Just substitute the data. River speed is 10 and what is the swimmer speed? It is 20. So 10 upon 20. How much do we get? You'll get 1 by 2. So sine theta is equals to 1 by 2. When do we get 1 by 2 in sine function? At sine 30. So what is theta now? It is 30 degrees. Now the question is angle at which the swimmer will make the strokes with respect to north. This is the north, right? So with respect to north, how much angle? 30 degrees. And that with respect to north, that means in which direction? It was in west direction. Did you understand this direction part? This was north. This angle was 30. So with respect to north, in which direction? West direction. So 30 degrees west is the answer. Very easy, right? If you remember this concept. Understand the concepts, and physics is very easy. One more question. In 1999, this was in 2019 NEET, and this was in 1999. A person aiming to reach exactly opposite point. Exactly opposite point means this is the shortest path case. That means without any push, he want to reach the exactly opposite point. On the bank of a stream is swimming with the speed. So what is the speed of the swimmer? 0.5. and at how much angle he was swimming with 120 degrees in the direction of flow of water. See, what was the angle theta that we have considered? It is theta from the shortest path. But here they gave the angle not from the shortest path, with the direction of flow of water. Let's make it simple. See, this is the direction of flow of river. Usually we consider. Okay, let this be the river flow. So point A, point B. This is the shortest path, right? This is the shortest path. From the shortest path, the velocity of the swimmer should make an angle of theta. And here 120 is not the theta. What is theta here? It is from the shortest path. But what is the angle given here? It is 120 with the direction of flow of water. Where is the flow of water? Flow of water is in east direction. So this total angle is given as 120. Got this clarity? Concepts are easy, but you also have to be a bit careful, right? Total angle is given. This is the flow of water. Flow of water is towards east. So with the flow of water, the angle made is 120. Now what about this angle? Shortest path is nothing but perpendicular path. So this is 90. Total is 120. Part is 90. So what about our theta now? It is 120 minus 90, 30 degrees. So the actual angle of strokes of the swimmer is 30 degrees. Now what we have to find? Speed of water, that means speed of river. So same concept, right? So apply sine theta is equals to velocity of the river by velocity of the swimmer. What is the velocity of the swimmer? It was given 0.5. So just substitute. Theta is 30. So sine 30 is equals to velocity of river unknown and velocity of swimmer 0.5. So sine 30 is 1 by 2. How can we write 0.5? 0.5 is nothing but 1 by 2, right? So 1 upon 2. So what is the river speed now? It is 1 by 2. If you send to that side, 1 more 1 by 2. So this is 1 upon 4. What is quarter? It is 0.25. So 0.25 meter per second. So answer is how much? Option A. So I want you to be careful with the angles also. Don't directly substitute. Ma'am said sine theta is equals to VR by VS and theta is 120. No. Diagrammatic observation is very important. Theta is the angle from shortest path, but here they gave theta with respect to the water flow. Clear? Okay. One more question. Two boys are standing at the ends A and B of the ground. Chalo. Let us assume this is the ground. Two boys A and B standing on the ground. Fine. Where AB is A, what is this distance? This is A meters. The boy at B starts running in a direction perpendicular to AB. So B started moving, and what is the direction of his motion? Perpendicular to AB. AB is along X. So perpendicular means B has to move in Y direction. And what is the speed? It is V1 meter per second. The boy at A, so B speed is V1. Boy at A starts running simultaneously. That means at the same time A also started running with the velocity V and catches the B in a time T. That means in a time of T, A is catching B. How can he catch? In what direction A should travel now? Should A also travel perpendicularly? Or what he should do? He should travel like this. This should be the direction of motion of A. Got my point? And what was the speed of A? It was V meter per second. Have you understood this? B was running perpendicularly. A also started running simultaneously, and A has to catch B in a time T. That means clearly understand here, in a time T, B was traveling with V1, A was traveling with V, and catching in the sense what? A should overtake B, isn't it? A speed has to be more, so definitely V is more than V1. Now, what is the question? We have to find the time where t is. They're asking the time. What is the formula for time? Time is nothing but distance upon speed, right? So let us divide this diagram into three segments. Let this be first segment, second segment, and third segment. We need distance by speed. If you see third segment, we have speed but we don't know the distance. If you see second segment, same, we have speed v1 but there is no distance. Take the first segment, we have distance, we don't have speed, but can't we find the speed here? This is the side of a right angle triangle, right? So what will be the speed here? Hypotenuse square minus side square. This is actually side, right? This is the hypotenuse. This is the other side. So can't you find the side AB? So side is equals to hypotenuse square minus another side square. So we have the speed on AB side. So just substitute now. Distance is A and speed is how much? V square minus V1 square. So what is the answer? Answer is option D. Ma'am, we don't have root for A. It was root A square. No, so root of A square is A again. So right answer is option D. Clear? Everyone? Fine. Now we'll move on to the next topic. Crossing a river in shortest time. This time the swimmer is not bothered about the path. River, you push me however you want. But my target is only to cross the river in minimum time as much as possible. So this is the target of the swimmer now. He has to cross in the shortest time. So how can we make it possible? Consider the diagram again because diagrammatically it's easy to understand. This is the shore, this is the river, and this is the direction of river flow. Okay. And what is this perpendicular path? This is the shortest path, right? Now swimmer will think this time his target is not to move in shortest path. His target is move in shortest time. So however river pushes, that is not, that will not bother him. So what swimmer will do? He will start swimming in AB direction. Because if he has to cross the river in shortest time, he has to swim along AB. He has to swim along the shortest path. So what happens? As usual, the river will push him. So the swimmer will be actually displacing in this direction. Got my point? Swimmer was thinking to move in AB, but actually he will move along AC. And what is this BC? It's called drift. Clear? Everyone? So this is the velocity of swimmer, this is the velocity of river, and this is the resultant velocity, or this is the v net of swimmer and river. Any difficulty? Kindly understand. If the swimmer has to cross a river in shortest time, he has to swim along AB. River will push him and the swimmer was forced to move along AC. And what is this gap between B and C? It is drift. Now, how do we find that shortest time, minimum time? Same formula. Time is nothing but distance upon speed, right? So here also you can consider three segments. We have a right angle triangle. Mm, let's take this segment 1, segment 2, segment 3. Two sides 1 and 2, one hypotenuse 3. So take the data whichever is available. Whether you take time for first segment or second segment or third segment, you will get the same time because time is scalar, right? So t along 1 equal to t2 along equal to t along the 3. This is same. So you just take the segment for which the data is available. Okay. So first suppose if I take, this is the width of the river, right? Let this be d. Width of the river d. Now if I apply it for first segment, what will be the minimum time taken by the swimmer? First segment, distance is d and speed is vs. If I apply it along the second segment, what is the minimum time? distance by speed, but this time distance is nothing but drift of the swimmer. Speed is nothing but velocity of the river. Understood? You can apply for segment 3 also. Then that time you have to take hypotenuse distance. If then for that case, for 1 and 2 distances must be available. You should know the width and drift. Then you can find distance for 3 and then you can apply distance by V net. But mostly we will be using either 1 or 2. So remember the concept. However you take the time for any segment, you'll get the same answer. So most important points: for shortest time, the swimmer has to swim along AB. For shortest path, he has to swim backwards at an angle theta. Is this point clear? Okay, so let's make it more clear by doing some problems. So this question was asked in 2019-98. Width of the river is 1 kilometer. So what is the width of the river? D. This is equals to 1 kilometer. Fine. The velocity of the boat is 5 kilometers per hour. The boat covered the width in shortest time. That means how was the boat moving actually along AB? So this is A, B for shortest time. This should be the direction of the swimmer, boat, both mean the same. Okay, something which was moving. Okay, so the boat has to move along AB. Now, what is the speed? 5 kilometers per hour. Read the question carefully. The boat has covered the width in shortest time. That means the boat was in motion. That means the velocity of the boat which they gave here, that is actually the resultant velocity of the boat. They have given actually resultant speed. This is not the speed of the boat on still water, because the river is in motion, right? If you see the question, the velocity of the river stream is, they are asking you VR. That means the river was moving, the river is in motion. So this is not the velocity of the boat in still water. This is the velocity of the boat in running water. So it's relative velocity. Relative speed is given. And where will be the relative speed? Just recollect the diagram. This should be the velocity of the swimmer or boat, and this is the resultant speed of the swimmer or resultant speed of the boat. Yes or no? So this resultant speed is given. Kindly read the question. Because the speed of boat in running water, that is actually the resultant speed. So V resultant is given 5 kilometers per hour. They are asking you velocity of river, and minimum time is given. What is the minimum time? It is 15 minutes. If you see the options, they are given in kilometers per hour. So 1 minute is 1 by 60 hours. So how much will you get? 1 by 4 hours. Now how do we find VR? How shall we do this? Any idea from your end? Time is available, distance width is available. So we'll do one thing. Apply the time for this segment. One segment, because for one distance is 1 kilometer and time is 1 by 4 hours. So you can find out the speed VB there. So for one, time is equals to distance upon speed. So time is 1 by 4. Distance is 1 kilometer upon what is the speed? It's nothing but velocity of the boat, boat in still water. So what is velocity of boat now? It is 4 kilometers per hour. Is this point clear? First point. We have to find velocity of river. Where is the velocity of river? In this direction, right? So let us consider it as two segment. We have velocity of river in two segments. So for the second segment, this is the velocity of river, velocity of boat, resultant velocity. Resultant is 5. Velocity of boat, just now we have simplified 4. And don't you think this is right angle triangle? So what will be this VR now? Very famous right angle triangle, 3, 4, 5 triangle. So hypotenuse 5, adjacent 4. So what will be the other adjacent? It will be 3. So velocity of river is 3 kilometers per hour. Or you can apply under root of hypotenuse square minus side square. Clear with this? Any difficulty? Very easy. Just understand, a boat is sent across a river with a velocity of, so what is the speed of the boat? 8. If the resultant velocity of the boat is 10 kilometers per hour, then the velocity of the river is, so resultant velocity, this is the direction of resultant velocity. How much is this? 10 kilometers per hour. And what is the velocity of the boat? This is 8 kilometers per hour. They are asking you what is the velocity of the river. So velocity of the river, how much? This is a right angle triangle again. So in a right angle triangle, how will you find the side? It is square root of hypotenuse square. Let this be side 1 minus side 2 square. So we need velocity of river. So that is equals to under root of V resultant square minus V boat square. So simplify this. 10 square is 100, 8 square is 64. How much will you get? 36. And this is 6 kilometers per hour. So answer is option B. My sincere suggestion, when you are dealing with relative velocity in 2D, catch the concept. Don't blindly go with the formulas. Concept is required here. If you take some questions, like we have seen motion in 1D, where directly we were using equations and much concept is not required there. Simply if you remember formulas and sign convention, you can do the problems. But relative velocity in 2D, diagrammatical understanding is required and a bit conceptual understanding is also required. Okay, so hope you have understood today's class, and in the next class we will see laws of motion and some questions related to uniform circular motion as well. Okay, so this is what for today. Any doubts in today's class? What did we discuss today? Today we have started relative velocity in 2D, and we have seen very two important cases: crossing a river in shortest path, crossing a river in shortest time. Okay, so believe in yourself and you will be unstoppable. Like, the famous hero Balakrishna's program Unstoppable, you will also be unstoppable. So just believe in yourself, keep 1000% of your hard work, okay, and give your best for your preparation. Okay, thank you so much. Have a nice day.